Here we're going to look at question 74 from the IMAT 2012 paper. So in this question, we're given three different configurations of some capacitors as set up in a circuit, and we're asked what is the increasing order of capacitance, i.e. the smallest first. So if you'd like to have a go at doing this question yourself, then please pause the video now, otherwise let's have a go at it together. So to try and answer this question, you basically need to just know how capacitors or how capacitance is added up in series or in parallel, or in situations such as that. And basically, the easiest way of remembering it is that it's just the opposite of resistors. So, with capacitors like this in situation 1 or configuration 1, the three capacitors are just in series to one another. So, we do the opposite of what we do with resistors in series, and that is that the total capacitance is found by doing the reciprocal total capacitance equal to the reciprocal of each of the capacitance of each of our components. So here, 1 over our total capacitance of this situation, C1, is equal to 1 over C plus 1 over C plus 1 over C, with C being the capacitance of each of the identical capacitors. In that case, these three add up together to give us 3 over C, so a total capacitance for configuration 1 of C over 3. Okay, so fairly easy. All that you've got to know is this first rule, which is just that it's the opposite of what you do with some resistors. Now, if we go ahead and look at our second configuration, then we can see that we have this series section here of two capacitors in parallel with this one capacitor here. So using the law that we just used to add up our three capacitors in series, we can do the same thing for our two capacitors in series here, and it's just going to give us this final capacitance of this section being C over 2. Which you can probably see by looking at this bit from the previous part. Then, with two things in parallel, two different sections in parallel, all we have to do is the opposite of what we do with resistors. So since with resistors we'd normally add the reciprocals, we just do the opposite, so we just add the two capacitances together. So we have the capacitance of this, C, plus the capacitance of this section, C over 2, giving us this total capacitance for configuration 2 of 3C over 2. Finally, in the third one, we have three different capacitors in parallel, so we just do the opposite of what we do with resistors, and we just add them. Whereas with resistors, we'd of course add the reciprocals. So this gives a final capacitance for the third configuration of 3C. Therefore, then, this first one up here is going to be the smallest, and the bottom one is going to be the largest. So the order is going to be 1, 2, 3, which corresponds to answer D given in the question.